The identities. Welcome to Natural Sciences for University students. All right, so 1 plus 2 tan squared x is equal to sec squared x. How do we prove this identity? Now, you can start with which either side you're comfortable with. All right, so to prove that this is true, actually, here's what we can do. We know from the fact that cos x squared plus sin squared x is equal to 1. This statement is well known, isn't it? Meaning that here, so keep this. So let me start with the left hand side. We are proving, so we have 1 plus tan squared is sin squared x over cos squared x. Meaning from here we have the common denominator, which is cos squared x. This into this will give me cosine squared x. This will give me sine squared x. And this identity is what is there. So I'll just put 1 over cos squared x. Also recall that 1 over cos x is just sec x. So if I've got cos squared x, meaning this will be sec squared x. That's all. It's done. Next. Is 1 plus cot squared x is equal to cosec squared x. Again, we can take the left hand side. 1 plus cot is just cos, okay? By the way, this is not cot 2x, but this is squared x. All right. So cot is just cos x. Now, because it is squared, it will be cos squared x over sine squared x. Here, common denominator will be getting sine squared x. Dividing and multiplying, x plus cos squared x. Recall from this identity, it's 1 on top. So we get 1 over sine squared x. Recall that 1 over sine x is just cosec x. So if there's a square, meaning this will be equal to cosec squared x. Just like that. We're good. Okay. What about this one? Whichever side. I'm usually comfortable with the longer part because it's easier to deal with. Okay, so with what we have here, we can get our common denominator, which will be 1 minus cos x and 1 plus cos x. Meaning if I divide here into there and multiply, I'm going to get 1 plus cos x minus dividing this one into here, I'll remain this one. But remember that the negative is multiplying everything here, meaning I'm going to have negative 1 plus cos x. Cos x and cos x will give me 2. This and this disappears. So I have 2 cos x over 1 minus, of course, this is just the difference of two squares. Like that. Now, from this again, if you make cos squared the subject of formula, you'll be getting this. Sorry, if you make sine squared the subject of formula, you'll be getting this. Meaning this is just the same thing as 2 cos x over sine x squared, like that. Now, we understand that what we have there is just the same thing as 2, everything being multiplied by cos x over sine x multiplied by 1 over sine x. We are aware, right? The 2 can stay outside. Cos over sine is just cot x. 1 over sine is cosec x, which now completes the answer to 2 cot x cosec x. And you're done. Next. The other one is root of 1 plus sin theta over 1 minus sin theta is equal to sec theta plus tan theta. How do we show this? The first thing that we can do is that we can actually rationalize the word the numerator or the denominator, whichever we are comfortable with. Okay, it is still very much fine. Okay, and this one is simple. Doing so will help us remove the root. So if I have, take this side, the right left hand side. Okay, 1 plus sine theta over 1 minus sine theta. Now everything is under the root. I can transform this one as, remember that the root can be distributed, 1 plus sine theta over 1 minus sine what? Theta. I can multiply both sides, all right, with 1 plus sine theta over 1 plus sine theta. Where am I multiplying like this? Because I'm trying to rationalize the denominator. Because I'm rationalizing the denominator, I need to multiply by the conjugate of the denominator, which is 1 plus sine theta. Multiplying here, these are the same, meaning I'll just end up having 1 plus sine theta. By the rules of sides, you should be able to know that. And this, well, as long as there's a negative and a positive there, meaning you are just squaring them. Okay, meaning we have okay, so we are going to have 1 minus sine squared theta squared, like that. And again, the same identity, this one here, is going to help us. This, all right, you can clearly see we have 1 minus sine squared theta, which just gives us cos squared, meaning we have 1 plus sine theta dividing by root of cos squared theta, which will give us 1 plus sine theta over what? Cos theta. Now, this can divide throughout. It's the same thing as 1 over cos theta plus sine theta over cos theta. Of course, we know what 1 over cos theta is. Okay, it just sec plus tan. Because the last one is tan x over sec x plus 1 is equal to sec x minus 1 over tan x. All right, just like the flipping it, eh? Oh, yeah, let's go. All right, so we have, let's take the left-hand side as usual, which is tan x dividing sec x plus 1. All right, so what do we do? What do we do? We can multiply both sides by the denominator. We can rationalize the denominator, meaning tan x over sec x plus 1 multiplied by sec x minus 1 over sec x minus 1, like that. Okay, meaning we are going to have tan x open brackets sec x minus 1 close here. Okay, here just sec squared x minus 1, just the difference of two squares. Okay, now there's something that we did here. We proved something. There's this identity here, meaning I can make tan square the substitute formula from here, and I'll be substituting there, meaning that I now have tan x over sec x minus 1 divided by what I'm having here is just tan squared x, where one tan and one tan will cancel. I'll remain with what? Sec x minus 1 over tan x. Proven, right? Good. So follow this channel if you want to learn more of this, and we don't just do mathematics, but I think you can see from the channel that we also have got other courses here. I'll see you. This is PVS the tutor.